Welcome to the deep dive. Today, we're looking at something pretty huge in space exploration, NASA's Gateway project.
That's right.
And specifically, the arrival of a really key part, the HALO module, which just landed in Arizona.
Exactly. Gateway is, well, it's going to be this future home, a critical link, orbiting the moon for the Artemis astronauts.
Like an ISS, but lunar.
Pretty much, yeah.
Yeah.
An international space station way out there supporting missions to the moon's surface.
Okay, so our mission today for this deep dive is to really get into what this HALO module arriving actually means. You know, its significance for getting humans back to the moon. We've got news reports, project updates.
Now, the timing itself is interesting. HALO actually arrived in Arizona back on April 1st, 2025.
April Fool's Day.
Yeah. It traveled all the way from Turin, Italy. That's where Thales Alenia Space did the initial assembly. Quite the trip.
Wow, Italy to Arizona. So HALO, it stands for Habitation and Logistics Outpost. Sounds important.
Oh, it is. It's basically the living room and workspace for the Artemis crews when they're in lunar orbit.
So this isn't just an empty can arriving. This is the core habitat module.
Well, it arrives as a primary structure, but the work in Arizona is crucial. It's about turning that structure into a fully functional outpost. Think of all the engineering needed for deep space living.
Right. And I gather it's not just about living space. There's science, too.
Absolutely. It's designed as a platform for scientific research in lunar orbit, a unique environment we haven't really studied from up close like this before.
Okay, so HALO touches down in Arizona April 1st. But it's not, like, ready to launch immediately, right?
Right.
What's the next phase?
No, definitely not plug and play. The immediate next step is all about outfitting and testing. Really rigorous testing.
Okay.
This is happening at Northrop Grumman's facility in Gilbert, Arizona. Got to make sure everything's perfect.
So when you say outfitting, what does that actually involve? Are we talking about installing the coffee machine or?
Huh? Maybe eventually.
Right.
But right now, it's the critical stuff. Command and control systems.
The brains.
Exactly. And the data handling systems. Managing all that information flow.
Makes sense. You need to talk to it, and it needs to handle all the data coming back. What else is getting installed there?
Power is huge. So energy storage, power distribution systems, and then thermal regulation.
Keeping things not too hot, not too cold. Crucial in space.
Extremely. The temperature swings are wild.
Yeah.
So that system is complex. They need to keep the crew and all the sensitive equipment happy.
Yeah, I bet. It's not like just fiddling with the AC.
Not quite. Then they'll be installing propellant lines.
Yeah.
These could be for small maneuvering thrusters, maybe even refueling capabilities down the line.
Okay.
And, of course, miles of electrical lines for power and data running everywhere inside the module.
So it's like wiring up a very advanced self-contained house that happens to be going to the moon? What about keeping the astronauts, alive?
Right. Well, that's where the radiators for that thermal system come in. They get attached. And then the internal racks.
Racks.
Yeah, big standardized racks where they mount the actual life support hardware. Also power equipment, the flight computers running everything. And the avionics systems. All the electronics for control and monitoring.
Wow. It sounds incredibly complex, like a huge, high-stakes jigsaw puzzle. What are the big challenges in putting all that together, making sure it all works?
That is a great question. I mean, integration is key. You have all these systems, sometimes built by different teams, different companies, and making sure they talk to each other, that they function perfectly together, especially under space conditions. That takes meticulous planning and, crucially, testing.
Okay, and HALO needs to connect to other things too, right? It's not just floating alone.
Precisely. They'll be mounting the docking mechanisms. These are the ports where the Orion capsule carrying the astronauts will dock.
Okay.
And where the lunar landers connect to take crews down to the surface and back, plus any other visiting vehicles in the future.
So HALO isn't just a place to stay. It's like the central station, the hub for lunar traffic.
You got it. And once everything's installed, then comes the really intense testing phase.
What kind of tests?
Oh, the works. Thermal vacuum testing, simulating the vacuum in extreme temperatures of space.
Right.
Acoustic testing, making sure it survives the incredible loud launch environment. And vibration and shock tests, simulating the physical stresses of launch and spaceflight.
Basically trying to break it here on Earth so they know it won't break up there.
That's the idea. Put it through its paces to guarantee it's ready for deep space.
Now, you mentioned the arrival, but the sources also talked about a celebration.
Yes. On April 24th, 2025, NASA and Northrop Grumman held an event to mark HALO's arrival at the Gilbert facility. It's a pretty big milestone.
Yeah, I bet. Who was there? Any big names?
Definitely. Leadership from both NASA and Northrop Grumman. People like Lori Glaze from NASA Exploration, John Olenson, the Gateway Program Manager.
Okay.
NASA astronaut Randy Bresnik was there, too.
Wow, astronaut representation.
Yeah.
Oh.
And Todd Erickson, Senior Advisor to the NASA Administrator. Plus, elected officials, local industry folks, academics, really highlighting the collaborative effort.
So what did they actually do at this event? Just speeches?
There were speeches, for sure, emphasizing Halo's importance. But attendees also got facility tours.
Cool.
And the main event, really, they got to actually see the Halo module up close.
That must have been impressive, seeing this piece of future history.
Absolutely. And they also had virtual reality demos, giving people a sense of what Gateway will be like in action.
A VR trip to lunar orbit.
Yeah.
Nice. Now, something else caught my eye in the notes, this Lunar Link system. What's that about?
Ah, yes. Lunar Link. That's a really critical piece of communication hardware. It's actually provided by ESA, the European Space Agency.
Okay, international collaboration again.
Exactly. And interestingly, it's designed to launch attached to Halo. It kind of rides piggyback.
Okay, so it gets a free ride. What does it do once it's there?
Its main job is communication, enabling reliable contact between everything operating on or around the moon crew, robots, landers, you name it, and linking all that back to mission control on Earth. It's the essential comms network for the moon.
That sounds absolutely vital. Can't have people working up there without a solid phone line back home, essentially.
Precisely. Constant, reliable communication is non-negotiable.
Okay, so while Halo is getting kitted out in Arizona, there's another major piece of Gateway being worked on elsewhere, right?
Yes, exactly. The power and propulsion element, or PPE, that's being assembled by Maxar Space Systems out in Palo Alto, California.
Power and propulsion. Sounds pretty fundamental. What does it do?
It's basically the engine and power plant for the whole Gateway station. It uses a very advanced, efficient solar electric propulsion system.
Solar electric propulsion. How does that work differently from, say, regular rockets?
Good question. Instead of chemical reactions, it uses large solar arrays to generate electricity.
Okay.
That electricity is then used to ionize xenon gas, basically. Strip electrons off the xenon atoms.
Right.
And then it accelerates those xenon ions out at very high speed using electric fields. That creates thrust.
So not a big fiery blast, but more of a gentle, continuous push.
Exactly. It's much lower thrust than chemical rockets, but it's incredibly fuel efficient. It can run for very long periods. Ideal for managing Gateway's orbit over years, making adjustments, station keeping.
Interesting. A different way of moving big things around in space. So how's the assembly going for the PPE?
It's moving along well. They're attaching the main structural cylinder to the big tanks that will hold the xenon propellant and installing the avionics shelves. That's where all the control electronics will live.
And I think I read something about the thrusters themselves being tested.
That's right. The actual thrusters that produce the push. The first of the 3 big 12-kilowatt thrusters was delivered to NASA's Glenn Research Center in Cleveland.
Okay.
It's undergoing acceptance testing there right now, making sure it performs exactly as needed before it gets shipped to Maxar later this year to be integrated onto the PPE.
So we've got Halo in Arizona getting its living systems sorted, and the PPE in California getting its power and movement systems built and tested. It really shows how these massive projects are spread out, doesn't it? Different teams, different places, all working on crucial parts.
Absolutely. Halo is the house, the lab, the hub. The PKE provides the power and the ability to actually move the whole station where it needs to go, keep it in that specific lunar orbit. You absolutely need both for Gateway to work and for the whole Artemis program, really.
Okay, so let's kind of pull this together. Halo arriving in Arizona. That feels like a really solid, tangible step forward. It's the core living space getting closer to reality.
Definitely a major milestone.
And we've got the Lunar Link coming for communications and the PPE making steady progress with its advanced propulsion. It feels like the pieces for this lunar outpost are really starting to click into place.
That's a great way to put it. Halo's arrival for outfitting, it makes the whole idea of having people living and working in lunar orbit feel much more real, less like science fiction. Yeah. And seeing the progress on the power and the communications alongside it.
Yeah.
It just shows how comprehensive this whole effort is. It's a massive international undertaking.
It really does get you thinking, doesn't it?
Yeah.
About having this permanent, well, semi-permanent outpost way out there around the moon. What does that actually unlock? What kind of new science becomes possible? What new exploration does it make going down to the surface easier or even going beyond the moon? It's exciting to consider.
It is. And maybe that's the big thought to leave with, As this gateway, this stepping stone in lunar orbit, starts to take shape, what are the long-term consequences? What does a sustained human presence beyond Earth really mean for discovery, for our future? The possibilities are pretty staggering.